Alright, quick question. Last video you saw how NumPy is faster than Python list, but speed alone is useless if you can't access the right data or manipulate it smartly. Because in real data analysis, no one says, give me all the data. They say, give me this part of the data, only these rows, only these columns. Now do math on it. And that's where indexing, slicing, and math operations come in. Today's video will make NumPy feel like a precision tool, not a blunt hammer. So let's begin. Okay, so first of all, NumPy indexing. So what is NumPy indexing? Indexing means accessing a specific element from an array. Just like Python list, NumPy also uses zero-based indexing. Let's create a simple array. And for creating that, let's jump into our VS Code. So here we are in our VS Code and let's create our first array list. So first of all, we have to import NumPy as NP and let's make a variable here which is ARR. So ARR equals to NP dot array and inside that we are just passing a list of number which is 10, 20, 30, 40 and 50. Now tell me if I want 30, where is it? Index 2. So for calling this, we have to write print AR and in the square bracket, we have to mention the indexing, which is 2 in that case. And yes, boom, you get 30. Now, why this matters in real life? So imagine sales data, temperature readings, or stock prices. You will often need first value, last value, or a specific day's data. Now, what if we write print and in the square bracket, we have -1. Yes, we got the last element. NumPy understand negative indexing too, and there the respect is. Okay, so let's move on to our second section, which is indexing in 2D arrays. So first of all, what is a 2D array? So for now, we are just creating a single line of array, which is giving the elements in the horizontal. But what if we have the multiple arrays, which known as 2D array, which consist of rows and columns? So let's create one. So data equals to np.array and inside it, we are passing three lists. So the first list is 100, 200, 300, comma. The second list, which is 400, 500, 600, and the third list, which is 700, 800, and 900. So this is a 2D array. Now think of it like rows equals to record and the column equals to features. So what if I have to access a specific element from there? So let's write print data and inside the square bracket, I am calling the row and the column. So I am calling from the first row and the second element. And yes, we got 600. So basically, we have our first row and in the first row, we have our second element. So basically, here the first row is the second row and the second column is the third column because we know the indexing factor of the Python, which starts from 0. Now, what if we have to access a full row? So let's get our first row, which has the indexing 0. So if I write print data and inside the square bracket, if I write 0, then it gives me the first row of that 2D array. Okay, so what if I have to extract a full column here? So for that, I have to write print data and inside the square bracket, I have to write colon, comma, 1. And it gives me the whole column here. Okay. So this is exactly how Analyst extract column for calculations. Now the third point, which is NumPy slicing, and this is where the magic starts. If indexing is picking one item, slicing is picking a range. Okay, so let's do an example of 1D array slicing. So first of all, let's create a 1D array. So ARR equals to np dot array, and inside it I am passing an array which has the values 10, 20, 30, 40, 50, 60. And now what I am doing is I am slicing these values. So here we get values from index 1 to 4. So for that, I have to write print ARR, and in the square bracket, I have to pass 1 colon 5, which means I have to get the value from the index 1 to the index 5, where 5 is the last index of the getting element. So it will give me the index minus 1. And yes, we got 20, 30, 40, and 50 here. Okay. So here is an Python rule which applies start included and excluded. So here, as we can see, we have 1. So 1 is included, but 5 is excluded here. That's why we are not getting the 60 here. So why slicing is powerful? Because in real projects, you analyze specific time ranges, you ignore initial noisy data, or you focus on recent values. Okay, so after the 1D array, let's jump onto the 2D array. So now we are going to slice the 2D arrays. So first of all, let's build a 2D array. So data equals to np.array, where we have 3 lists over there, and the elements are 20, 30, 40, 50, 60, 70, 80, and 90. Now, how can I get the first 2 rows and first 2 columns here? So for that, I have to write print data. For the first, I have to write 0 colon 2, comma, and for the second, I have to write 0 colon 2. Now, what we get is our first 2 rows with the first 2 columns. So we get 10, 20, 40, 50. What if we want to get all rows but from the last column? So for that, we can write print data colon comma minus 1, and boom. That's feature extraction. This concept is heavily used in machine learning, image processing, or Pandas under the hood. Okay, now let's jump on to NumPy mathematical operations, and here we are not using any loops. So in Python lists, to add 10 to every element, you need a loop, but NumPy says, sit back, I have got this. So we have an array which has the value 10, 20, 30, 40, and now I am going to add 10 to every value. And for that, we have to just write print ARR, which is the array variable, plus 10. And we got the result 20, 30, 40, and 50. No loop, no headache, pure speed. What if I have to multiply the values by 2? So I have to just write print ARR multiply 2. Same for the divide. So I have to write print ARR divide 2. And this is called vectorized operation. And this is why NumPy is fast. Now here is a real business example, which is very important. So imagine this is a monthly sales data. So sales equals to np.sales, and we have the sales price over there. So 10,000, 12,000, 15,000, and 13,000. Now, what if prices increase by 10%? So for that, what we have to do is we have to just write print sales multiply 1.10, which is the 10% increase in the overall price. Now, if we want the total sales, so what we can do is we can simply call a function here. So sales dot sum, which is a function of NumPy or the NP. Now, if we want the average sales, then what we can do is we can just call the function mean over there. So sales dot mean, and it gives us the average sales value. Now, what if we have a lot of data and we have to find the maximum and the minimum values? So for that, we have to just write sales.max or sales.mean. And this is real world reporting. No fake examples. This is what analysts actually do. Okay, so here is a bonus power for you, and we are going to cover conditional operations. So let's say you want only high performing puts. So for that, what we can do is we can write print sales, and in the square brackets we can write sales which are greater than 12,000, and it gives us the result or the values which are greater than 12,000 only. So this is how we can also do the conditional operations directly in the data. And this is used for performance filtering, threshold analysis, or for the alert systems. Now, here is a final summary. So, today you learned how NumPy indexing works, how slicing helps extract meaningful data, how math operations work without loops, how NumPy is used in real business scenarios. At this point, you are no longer learning NumPy syntax. You are learning how data analysts think. And in the next video, we will combine some very great tricks about the visualization. So now we are going to cover the visualization part of the data science. So just stick with us, like, subscribe, and comment in our videos. We will see you in the next video. Till then, goodbye. Happy coding.